Hey folks, this is my first video on a module that I'm doing on exponential functions, and so it's just kind of a basic definition of what we mean when we discuss exponential functions and what the heck they are. Let's go and start with the definition of what we mean by an exponential function. We say an exponential function, we'll call this, how about f of x? An exponential function with base a is any function that appears to look like this, where we say a does not equal 1. I mean, one could necessarily consider how boring would that be if you took 1 to a power of x, okay? But this is actually one of the first examples that algebra students study of what we call a transcendental function. It's not an algebraic function like polynomials or rational functions where we have a polynomial over a polynomial, but transcendental functions. And so the interesting thing to consider here is this. You know, we discussed several different types of polynomial or exponential functions. We can make some up here. We say f of x equals maybe like 8 to the x power, or we could have some g of x. Why don't we call g of x 8 to the negative x? That'd be a good one to look at in this video. And we say h of x, we'll call h of x, how about 0.8? 0.8 to the x power. These are all really good ones to look at now that I consider it. But these are all different examples of exponential functions. We'd say f is an exponential function with base 8. That is the base of our exponent. Of course, g here also has a base of 8. We're going to kind of manipulate this using some algebraic properties of exponents. And then h of x as a base of 8/10. Okay. So digging right into this, I just want you to know, interesting thing about exponential functions is that we allow x to be any real number, and so that is like negative exponents. How about 0 for an exponent, or even possibly like a decimal. Okay, so if we said, just for instance, given f of x is this, why don't we go find f of pi? So maybe I want to go find f of pi, and of course we could just scribble this in as 8 to the pith power. Crazy thing is we are used to, you know, taking exponents that are taking bases to whole number exponents. Well, if we said 8 to the pi, it's easy. Just grab a calculator. 8 to the power of, you know, the pi key here. Enter 687.291-ish. So we'd say 687.3-ish. The interesting thing to keep in mind here is really just this. You know, pi is 3.14. So this is absolutely reasonable to say, well, if we took 8 to the third power, of course, we'd get a number that's like 8 times 8 is 64 times another 8. Okay. In this case, we get something a little bit bigger than what we would have gotten if we take 8 to just the 3. 8 to the 3.14 would be about this. So it is possible to take exponential things to weird bases. So I don't know. Let's mess around with g here. How about we do a few things with this? First of all, let's find g of, why not, g of a half. You know, we can have rational exponents. This is actually absolutely the case. So we could say this is 8 to the negative. Now we're plugging in this here as a half. Okay. So before we kind of continue here, I want to mention one thing. This is the same thing as 8 over 1 to the positive x power. But recall from algebra, if you had something to a negative power, so we say 8 to the negative x, we can actually take this power here, 8 to the negative x, and make this positive. All we have to do is take its base and cross it over this bar on a fraction. Okay, so if I were to take the 8 and put it downstairs now, let me clean this up a little bit here. 1 over 8, and now my 8's down in the basement. All that does is it switches the sign on the exponent. So this is true for anything. You know, if I dig around up here, we say, like, if I said a squared, b to the negative third, c to the fourth, all over d to the fifth. This is the same thing as a squared, c to the fourth on top. They had positive exponents. We'll leave them alone. But we could just take this base b right here, b, and throw it downstairs. We say it becomes b to the positive 3 now. D to the fifth. These equivalent expressions, well, they're equivalent, okay? So 8 to the negative half, we could say this is the same thing as 8 to the negative 0.5. This is totally fair. We could say this is the same thing as put it over 1. We could say throw 8 downstairs. Same thing as 1 over 8 to the positive 0.5. Now, regardless, let's go ahead and get the calculator. We can type this in. You know, calculators have no problem doing this. 8 to the power of, let me find my negative key here. There it is. We say 0.5, negative, enter, 8 to the power of 0.5. Well, maybe it doesn't want to go out that many decimal places. What if I pull open another calculator here? Thanks for being patient with me. Your almighty calculator, this one says. 8 to the power of, we got a power of key here. Jeezy Joe. Sorry guys, 8 to the power of negative a half. Simply put, we could do this and we say it's the same thing as 1/8 to the positive a half. Let me just adjust this here. 1/8 to the positive a half. Okay, and all I did was reciprocate what we had started with. So 8 to the negative a half is the same thing as 1/8. It's reciprocal to the positive 1/2. And let's see if it'll allow me to do it on my calculator now. We say 1/8, so 1 divided by 8, of course, 0.125, to the power of 0.5. And we get this here. This is much better. So about 0.3536. So approximately 0.3536. So better calculator would give me better results there. And we say 0.8. 0.8 to the x. Why don't we take this to the negative 2.5? So we say h negative 2.5. This is simple. We just say 0.8 to the power of negative 2.5. We plugged in a negative here. So we say negative exponent. Well, we could rewrite this as a positive exponent. We'll just put this downstairs, and it'll be to the positive 2.5. And this would be the same thing as 1 over 0.8 to the positive 2.5, since I reciprocated it. The other thing I want to point out here is the basement says 8/10. So this is the same thing as 1 over 8/10 to the positive 2.5 to the positive 2.5. And then when you divide by a fraction, you really multiply by the reciprocal. So this is the same thing as 10/8 to the positive 2.5. All different ways to express this. Really, all I want to know is that you just type this into a calculator and find it. So 8 to the negative 2.5. And again, with my calculator woes here, we'll find the reciprocal of 1/8. How about that? So we say 8/10. That'd be 8 divided by 10. Is 0.8. So if we reciprocate this, we get 10 divided by 8. That. And then we'll take this to the positive 2.5, so the power of 2.5, about 1.747-ish. So this comes out to be about 1.747-ish. But anything that's exponential really is just anything of this form where a is not 1. And the exponent is the independent variable. Cheers.